Today's lesson is 3.2 in your textbook, Working with Exponents. And the learning goal today is that you will be able to correctly identify the parts of a power and that you will be able to, by the end of the lesson, evaluate expressions involving exponents. If you haven't done the investigate already, you should be doing that first. Okay, so this is a power. It consists of two parts, the base and the exponent. The whole thing is considered a power. Sometimes it gets confusing because sometimes a power like this, for instance, might be said to be 2 to the power 4, and so you might think the power is just the 4. But the power is the entire thing. It has to have a base and an exponent. Okay, but we do say sometimes 2 to the power 4. Okay, so 2 to the power 4 is a power with a base of 2 and an exponent of 4. And in its expanded form, it's really just repeated multiplication. So it tells you take the 2 and repeat it 4 times, multiplying it by itself 4 times. It is not 2 times 4, which is a very common mistake. Okay, so it's 2 times 2 times 2 times 2. 2 times itself 4 times. And we know that 2 times 2 times 2 times 2 is actually 16. Okay, so this is exponential form as a power or expanded form. So these are exponential forms, these are powers, and it says write in expanded form and then evaluate. So let's go ahead and do that. So this would be 2 times 2 times 2 times 2 times 2. That's the expanded form, and if we wanted to evaluate this, 2 times 2 times 2 times 2 times 2, 2 to the 5th is 32. So you can calculate this on your calculator. Every calculator is slightly different, so I can't tell you what yours will do, but sometimes it's y to the x, sometimes it's x to the y, the button, and sometimes it's this funny little chevron, this little hat key that you use on your calculator. So you're going to have to get to know your calculator to figure out what 2 to the 5th is, or you can alternatively just punch in 2 times 2 times 2, which of course gets long. In this particular example, we see that we've got -3 cubed. The base is -3, the exponent is +3. So the expanded form of this is -3 times -3 times -3, and that is equal to -27. -3 to the 4th is very similar. It's just -3 times -3 times -3 times -3 one more time. Oopsie, sorry, no, I've got too many in there. And that's going to give you +81. So take away from here that if you've got a negative in your base to an odd exponent, your answer is always going to be negative. If you've got a negative in your base and your exponent is even, you're always going to have a positive answer. Okay. This one, I'm going to try and keep the question C showing. This one is different than this one because the base is actually just the 3. If there's no bracket, you don't assume that the negative is being put to the exponent. It's not part of the power. So the way we would write this, and this is a very, very important concept that you need to grasp, is we would take the negative, put it out in front, and then we would take the 3 and multiply it by itself 4 times. Well, we know that a positive number multiplied by itself any number of times is going to be positive, and so 3 times 3 times 3 times 3 is actually +81, but the answer has to be multiplied by this invisible negative in front, which is like an invisible -1, if you will, but we don't write the 1. So our answer here is -81. Now I want you to take a second and work with your calculator on this, because Your calculator is, all calculators are slightly different, and I'll pull the class when we get to this part, but you'll see that some calculators, if you want to get the correct answer here, will require you to put the negative at the end. So you will have to do 3 to the 4th and then multiply it by -1. Or you might have to put it like this, negative bracket 3 to the 4th. Or you might have to do this. Any of those are going to give you, hopefully, -81 as your answer. Some of you might be able to put in this just as is, -3 to the 4th. And depending on your calculator, you might actually get the -81 answer. Practice over here with this one and see what happens. When you put it in a bracket, you should always get the correct answer. -3 to the 4th. It should always give you 81. So your calculator might lie on this one. If you put in -3 to the 4th like this, your calculator might actually give you +81, which means you've got to be very careful when I ask you a question like this. You can't trust your calculator. Your calculator lies and gives you the wrong sign. So you've got to get to know your particular calculator. If your calculator doesn't do this properly, you've got to make sure you do it one of these ways. Okay. So 3.5 cubed is just 3.5 times 3.5 times 3.5. And when you do that on your calculator, you get 42.875 exactly. Now, if it had asked us to round to a nearest decimal place, then we might want to consider rounding it. But it didn't say in the original question to round, so we're going to keep all 3 decimal places for this one so that we have the exact answer. So I want to talk a bit about decimals and fractions here. The rule in this course and throughout the rest of your high school career will be that if you see decimals in your question, in your original question, you will be allowed to include decimals in your answer. However, if you don't see any decimals in your original question, like this one, if you see a fraction, you cannot convert your fraction to a decimal and work with decimals. You need to keep it as a fraction and work with the fraction. The exception to that is in a word problem. We allow you to use decimals in a word problem. Okay? So no decimals in the original problem. That means that you cannot have decimals in your answer, except if it's a word problem. So this power is 2/3 to the power 3, and so the thing that you need to notice about fraction powers is that if you have a base that's a fraction, if it's in brackets, it means the numerator is put to that 3rd power, and so is the 3. So this is 2 cubed over 3 cubed. And it's important that you notice the brackets in these cases, because if there is no bracket, it means something completely different. So now just multiplying fractions, tops by tops, bottoms by bottoms, you remember, so 2 times 2 times 2 is 8, and 3 times 3 times 3 is 27. So you end up with 8 over 27 here. So let me just give you some examples of when you would be very wise to watch for brackets. This looks like 2/3 squared, sorry. Oh, here, I'll keep it the same, cubed. But it's not. It's actually only 2 cubed. Because there's no bracket around the fraction, the 3 only applies to the number that it is near. Okay? So you have to be careful about that, because if you want to write, say, if I asked you to write, what's 1/2 cubed? You have to write it like this. You cannot write it like this, because really that's just 1 cubed. So 1/2 cubed is 1 over 8, and this one is 1 over 2. Okay, they're completely different answers, so you have to be really, really careful with your brackets as we go forward with our algebra and math. The other thing is you want to be careful doing this on your calculator as well, because sometimes you might type in 2ABC3 and then apply the exponent button, and you might end up with 8/3 as your answer. You have to be really careful to include brackets. Okay, so and again, every calculator is different. You should experiment right now with it and see what happens with your particular calculator and how you actually have to input your fractions in order to get the correct answer. All right, we're going to do this word problem now. Which container holds more popcorn? How much more? Round to the nearest cubic centimeter. Cubic centimeter means centimeter cubed. All right, this is obviously a cube because all of the side lengths are the same. This one obviously a cylinder. And so you do have a formula sheet that I've given you. You are to keep that for the entire course. You can use it on every test because even though we're not studying cubes right now, there are word problems that may come up that involve these 3D shapes, and you will need to have access to the formulas. We're not expecting you to memorize the formulas, although you might have some memorized by the time the course is done. So the volume of this cube is given by, well, a lot of you would think length times width times height because that's the volume for a rectangular prism. But in fact, a cube, because all of the side lengths are the same, can be written as s cubed. And s cubed is just 9.2 cubed. And I'm just going to grab my calculator. 9.2 cubed is exactly 778.688 centimeters cubed. I'm going to leave it for now and I'll round later. All right, for the volume of the cylinder, I'll just write volume sil. This is the volume of a cylinder is base area times height, and the base of a cylinder is a circle, so this is pi r squared times the height. Did I say over the height? So it's pi r squared times the height. All right, so pi is just pi, it's just a symbol, so for now we will just leave it. The radius is half of 10.4, so I'm just going to write it in as 10.4/2. And I'm going to square that, r squared. And then the height is 9.0. Notice how I'm putting brackets in. I'm not using time signs anymore. We try to get away from that in high school. Okay, even though I've used it up here without brackets, but more frequently we use brackets. Okay, so again, BEDMAS tells me that I cannot multiply pi by 10.4/2 because this exponent has to be dealt with first. So I'm going to take 10.4 divided by 2, which is 5.2 obviously, and I'm going to put that to the second power, or I'm going to square it. So this is going to be pi times 27.04 times 9. And then I'm going to use my pi button instead of just using 3.14. I want to keep my answer as accurate as possible. So I am just going to find the pi button on my calculator. So take a minute to look for that if you can. And then just use that times 27.04 times 9. And that's going to give me, now this one, because pi goes on forever, we're getting a very long answer on our calculator, so I am going to round to 2 decimal places here. So 764.54 approximately. So I put that little dot there to show that I've rounded. And again, it's centimeters cubed. So instead of writing something like this, some of you might be tempted. I'm just going to do this one in green. I don't want you to do something like this. Okay, so now we know the two volumes of the two solids, and we could just do something 778.688 minus 764.54 equals, and I have to grab my calculator to see what that equals. And let's see, 778.688 minus 764.54 equals approximately 14.148. I don't want you to do something like this as your final answer. I know that's a true statement. I know that that minus that equals about 14.148, but I don't care about that. What I care about is you explaining why you're doing that calculation. You're doing this calculation because you want to find the difference between these two quantities, because the question is asking you how much more is in one container over the other. So rather than doing something like this, and I really want you to get away from this, if you are ever doing something like this where you've got two numbers equals another number with no variable, I want you to ask yourself, is that what I should be doing? So instead of doing that, what I would like you to do is I would like you to understand that you are solving for something unknown. So you are going to, and we normally do this at the beginning at the top, but it's awkward here because there is no sort of room here. So I'm going to say let x, I'm going to introduce a variable, represent the additional amount of popcorn in the larger container. And I always think about what my units are for that variable. And in this case, I know because they were both, these quantities were both in centimeters cubed, that it will be in centimeters cubed. Okay, so now I can say, all right, I know how to calculate that. It's going to be x is going to be derived from taking the bigger number, 778.688, minus 764.54. And that's going to be an approximation because this number is already an approximation. And normally I would, let's see if I can extend that page down. So now, when I take my difference, it's going to be approximately 14.148, and when I round it, it's going to be 14 centimeters cubed. I'm going to put in a therefore statement. Therefore, because this is a word problem, we always put a therefore statement in. Therefore, the cube holds 14, you could even put the word about because we round it, 14 centimeters cubed more popcorn. Okay, a couple things just to talk about again with regards to presentation. Notice how I did not put cubed, I did not put the units anywhere in the body of my work. I only put them in at the end, the centimeters cubed part. Same with over here and over here, just in the very last line. And then of course I always put them in the conclusion. Okay, that is the conclusion of our lesson. Thank you.